There are two categories of while loops we're going to discuss in this chapter. The first is called the count-controlled loop. We saw an example of the count control loop earlier when we wrote out the phrase hello world 10 times. The loop control variable kept track of how many times hello world was printed so that it was only printed 10 times. We're going to look at two more examples of count-controlled loops in a minute. The other type of loop is the sentinel-controlled loop. A sentinel is a value checked for in the condition. So for example, you might say, while not at the end of a file, or while the current value is not equal to -1, something like that. We'll look at sentinel-controlled loops in a future lesson. Now let's concentrate on two examples of count-controlled loops. The first example I want to look at is calculating the interest on a bank account. A fairly standard textbook problem. So to do that, we're going to need a couple of double variables, balance and rate. We're also going to need two integer variables, years and count. Now we're going to prompt the user to enter the starting balance of the bank account and get that value into the variable. Then we need to prompt the user for the annual interest rate, get that variable into rate. Then we need to prompt the user on how many years we want to calculate interest. Store that in years. Our loop control variable will be count, so we're going to set it equal to 1. Then we're ready to start the while loop. For the relational expression, we're going to say while count is less than or equal to years. Then open the statement body. Balance is equal to balance times rate, which we'll shorten to balance times equals rate. I'm going to use rate in the form of 1.0x or 1xx rather than do 0.0x, whatever that number is, and then have to add back the principal. You'll see how that's going to work in a minute. And then finally, we need to increment the loop control variable count by 1 so that the loop will eventually stop. Next, all we have to do is display to the user what the value is of their account, which we'll do right now. And that should do it. Let's build and run the program and test it with some numbers. So we'll say the starting balance is $1,000. The annual interest rate is 2%, which we'll enter as 1.02. And we want to calculate that for 10 years. And the balance after 10 years will be $1,218.99. So let me go over again the steps in creating a loop with this example. The first thing you have to do is declare and initialize the loop control variable. So we declare count and initialize it in two separate statements. The next step is to write a relational expression that can eventually become false. Count less than or equal to years is our relational expression. The third step is to have a body that does some type of work. Here we're trying to calculate the new balance from the old balance and the interest rate. And then the last step is to modify the loop control variable so that the relational expression can eventually become false. And we do that by incrementing count by 1 each time through the loop. Now, one thing you might do, if you're having problems getting your answers to come out exactly the way you want them, you might put a cout statement in the body of the loop just to verify that the loop is working correctly. So after the balance is computed, I might want to say, oh, I want to see the count, what year we're on, and the balance at that time. So I add this cout statement to the body of the loop, build and run again. We'll enter the same numbers, 1,000, 1.02, and 10. And now, besides getting the final result, we also can see how the program is computing the balance through the iterations of the loop. After the first year, the second year, the third year, and so on and so forth. So that's just a nice way to do a little debugging and to check your work and to watch actually what's going on while the program runs. Now, let me show you a shortcut we can make in this program. The loop control variable doesn't have to be a separate variable from the other variables in the program. What we could do is use years as our loop control variable as well as being some data we need for our computation. So what we're going to do here is change the relational expression to say while years is greater than 0, compute the balance, display the balance, and then subtract 1 or decrement years by 1 each time through the loop. The first time it'll be year 10, then year 9, then year 8, then year 7, then year 6, and so on and so forth down to 1. Then when years become 0, the relational expression will become false and the loop stops. Let's comment out our displays. We don't need to see them. And let's build and run the program again. Use the same numbers, 1000, 1.02, and 10. Now we do have to make one other modification. We have 0 years, which is not exactly right. So we might just want to change our output somehow to say, at the end of this period, your balance will be 12/18/99, or something like that. I'm not going to make that change here. That's not really consequential to the program. But it is interesting to see how, when you make a change like this, how other parts of the program that you weren't really thinking about can change also. Now let's move to another example of a count-controlled loop. First, I'm going to comment out the lines of this program so that they're still on the screen, but they aren't executed. A problem I often give my students is to tell them that they're working with a programming language that only has 2 arithmetic operators, addition and subtraction. And then I ask them how to do multiplication with only addition, or how to do division with only subtraction. Well, if you think about a typical multiplication problem, 5 times 3, what that problem is saying is add 3 5 times to get the result, 3 plus 3 plus 3 plus 3 plus 3, which is equal to 15. So clearly we can do that with a loop. So let's write the program to do that. We'll create a couple of variables, num1, num2, product, and count. I'll do the standard loop control way this time rather than leave it out, but you could certainly experiment on your own and change it later. We need to initialize product to 0 because we're going to be adding into it. And with C++, you should always initialize a variable if you're going to assign data into it. I'll show you what happens when you don't in just a minute. We'll set count equal to 1 since it's going to be our loop control variable. We'll prompt the user to enter values for the 2 numbers. And put this in num2. Now we're ready to write the loop. We've already initialized the loop control variable, so we can say while count is less than or equal to num1, product plus equal num2. In other words, take the value of num2 and add it into the current value of product and keep a running total, and increment our count control variable by 1 count so that it'll eventually become false. Now we can display the result, cout num1 times num2 equals product. Let's give it a shot. Build and run. First number is 5. The second number is 3. 5 times 3 is 15. Let's go through the steps of the loop one more time. We declare and initialize a loop control variable. In this case, it's count. We declare it and we assign it the value 1. We write a relational expression, count less than equal to num1. We get some work done in the body of the loop. That's where we add num2 into the product. And then finally, we modify the loop control variable so that the relational expression will eventually become false. Let's try it one more time. We'll do 12 and 12. And 12 times 12 is equal to 144. Those are 2 fairly classic examples of count-controlled loops. And in my next video, we'll talk about how to write sentinel-controlled loops.